So in this video, I'm going to introduce about the overview of Calcit.js. For people who don't know, Calcit.js is a toy language based on inspired by ClotScript. It's implemented in Rust for performance. It borrowed many ideas from ClotScript, and you even see it's even though it's not highlighted. So this one, it uses macros to define the core of the language. Itself is a Lisp dialect, despite it's using indentations. If you mentally add parentheses here and here and here, here and here, and you will get very familiar with syntax with Clojure. So in this video, I'm going to use this demo, which is using the tree editor of Calcit.js, and it looks very different. It's very still different. But anyway, you can see it's a Fibonacci function. It's calling. It's returning number one, the value 1, and when the number n is little than 2, and it's adding the results here. Let's go in. Let's run it. With command line, and when I call it in reload, is just print the value. It's a very slow implementation of Lisp. So since I'm going to introduce the arrow view, I'm going to produce an arrow here by turning it into something that will fail. This one is native add. It takes only two arguments, and this time it's taking a hash map. So it produces an arrow, and called. So this arrow is very obvious. You can read from the text and understand what's happening. There might be other situations you want to know more about how the arrow is produced. So you need to read about the core stack. Since Calcit is not Lisp, it suffers the same problems like many Lisps. Like if you find something, if you want arrows, if you found arrows from macros or somewhere deeply nested, you may be missing in finding the problem. So in Calcit, I just collect more information from the Calcit stack, and now you can read the file to know what's happening. So it's kidding. I'm not going to read it manually. So also I built a tiny tool with Calcit.js. It's JavaScript, so I can parse the file and what's the code? So the file is called serial file. It's using data. It's data syntax. It's very flexible syntax, so it's also representing data in this way. Now it's a hash map. So there's a stack in a vector inside the stack field. Now I can pass it into a viewer Calcit viewer, and at the bottom of the stack it's using maybe the top of the stack it's calling native internal end with two values. So that's why it's throwing an error. When you want to know more about how it's happening, you go to the code stack and find its this time it's a syntax. The if syntax, it takes three nodes and three syntax tree nodes, and it calculates this one. And where was it called? It's called in fib, with one value 1 is used applied. And yeah, you can go deeper and deeper to see where it's called. It's called from 7, 8 up to 17 and 18. So 18 is where we called from here. And now doing it again. There might be some bugs. Anyway, so this is a very quick demo of the error viewer. So in the code stack, I calculated the values, and for syntax, I calculated the tree, the nodes. So usually it's very convenient since Lisp everything is an expression, and even the syntax tree can be captured in a very simple way. So I don't have. This is a very simple example. In my previous projects, I have more complicated example. Usually, it's very large arrow information data. I copied it to the editor, and now you see this call is called this function. This one is marked as macro. It's calling here. It's calling with no argument function here, and the macro and the run the app function and the container. This one. The argument is missing. There should be an argument. And since when a macro is called, it taking very many nodes, and want to go to here. Here it is saying empty do is not okay, since it's not allowed in Calcit. And it's where it's called. It's called here. In my previous code, I used the do, but with an empty body, it was not allowed. So I can extract here. Okay. The details of the macro is captured. So these are the demos of the error viewer I made for Calcit, and so you see since the details of the code stack is captured, and you can view the stack very simply from the code stack, and so it can be more easy to figure out where's the problem when there's an error produced. Even if there are macros, it's always said it's hard to debug macros. So we just need some more visual way to debug it. Okay, this is my demo. Thanks for watching.